In previous class we discussed about ionization energy. Now we will discuss about electron affinity. Okay, so what is the meaning of electron affinity? Atoms of some elements gain electrons while forming ionic compounds. Okay, what is the meaning of ionic compounds? We will discuss in next chapter. Means you know about compounds now, how the compounds will form according to octet rule. By depending on the octet rule, some atoms of some elements are giving the giving the electrons to another one, atoms of another elements taking the electron from another one, like that. After taking that, follow the octet rule, and by depending on that, compound will form. Okay, about the formation of this compound we will discuss in next chapter. So atoms of some elements gain electrons while forming the ionic compounds. Means in previous class also Na plus Cl minus in that I said no. So some like that, some are gaining, some are losing, like that. Okay, so atoms of some elements are gain electrons while forming the ionic compound. An atom is able to gain an electron only when the electron outside the atom is attracted by its nucleus. So this attraction involves the liberation of energy. So an atom is able to gain electron only when the electron outside the atom is attracted by its nucleus. Okay, so atoms of some elements gain electrons while forming the ionic compounds. So an atom is able to gain the electron only when the electron outside the atom is attracted by the nucleus. These attractions involves the liberation of energy. So the electron affinity of an element is defined as the energy liberated when an electron is added to its neutral gaseous atom. So by this we can say the electron affinity definition like this: electron affinity of an element is defined as the energy liberated when an electron is added to neutral gaseous state of atom. Okay, the energy is liberated when an electron is added to the neutral gaseous atom is called as electron affinity. Electron affinity of an element is also called as electron gain enthalpy of that element. Okay, so here sometimes atoms gain the electrons when it is forming the ionic compounds. Okay, so this atom is able to gain the electron when the electron outside the atom is attracted by the nucleus. So this attraction involves the liberation of energy. Okay, that time when it is attracting the electron, that time energy is liberating. So by that we can say the definition of electron affinity is like this: the electron affinity is nothing but the energy is liberated when the electron is added to the neutral gaseous atom. Okay, so that is called as electron affinity. Electron affinity of an element is also called as electron gain enthalpy of that element. Here one equation is there: M plus electron minus gives rise M minus plus Ea, electron affinity. Okay, here M plus electron minus gives rise M negative plus Ea, electron affinity is there. Means what is the meaning of that? Means M means neutral gaseous atom, E means we are adding electron to neutral gaseous atom, gives rise M minus. Why M minus came? When electrons will take, the negative symbol will come or not? In previous class we discussed it. Yes, that's why M minus will form. Okay, means neutral gaseous atom. We are for neutral to neutral gaseous atom we are adding one electron. Then what will form? It's took electron now. Then M minus will form. Okay, plus it is liberating some energy, no? That energy only Ea, electron affinity. That energy only called as electron affinity. Okay, so the energy liberated when an electron is added to uni-negative ion of the element is called as second electron affinity of that element. Okay, so here, okay, we have one more equation. What is that? M minus plus electron gives rise M minus 2 plus E2 is there. Means here the energy liberated when an electron added to uninegative ion. Here which is uninegative ion? M minus. In the above equation M minus is formed, that is called as uninegative ion. So we are adding one more electron to uninegative ion. Okay. Second equation what? M minus plus electron minus gives rise M minus 2 plus EA2. Means uninegative ion upside form M minus. Okay, we are adding one more electron to that uninegative ion. Okay, M minus means uninegative ion plus electron minus means we are adding one more electron. Then what will form? M minus 2 means we are added 2 electron. That time also energy is releasing, no? That energy is called as second electron affinity. That energy is called as second electron affinity. Okay. So the energy is liberated when electron added to uninegative ion is called as second electron affinity. So in the above equation, first M plus electron minus means M is neutral gaseous atom. For that we are adding one electron. Then what happened? We are adding electron, no, means taking electron, no, M negative, M minus will form, means uninegative ion will form. That energy releasing, no, that is EA1, electron affinity 1, or E1 also we can call. So here uninegative ion is formed, no? So that uninegative ion is M minus. For that we are adding one more electron. Okay. So one more electron we are added. That is electron minus means one more electron we are added. Then what is forming? M minus 2. It will form M minus 2. Okay. Plus E2 means we are adding one more electron to uninegative ion. That time also that is releasing energy. That energy is called as electron affinity 2. Okay. However, practically no element shows the liberation of energy when the second electron added to its uninegative ion. It does not mean that dinegative or trinegative ions do not form. Okay, they do form, but for adding second electron, energy in another way like bond formation must be given. Okay, so electron gain enthalpy values decreases as we go down in a group. Okay, electron gain enthalpy values decreases as we go down in a group, but increases along the period from left to right. Okay, so electron gain enthalpy values decreases as we go down in a group, but increases along the period from left to right. And metals have very low electron gain enthalpy values, and alkaline earth metals have even positive values. Note that the negative sign for energy values in the table indicates that the energy is liberated. Okay, if the negative sign is there, means that by that we can understood that the energy is liberated or lost, and the positive sign tells that the energy is gained or observed. Okay, positive sign, it is explaining about it is gaining energy or observing energy. We will discuss about electronegativity. Okay, so what is the meaning of electronegativity? The ionization energy and the electron gain enthalpy are properties of isolated atoms of elements. Okay, so there has been need to have comparing a scale relating to the abilities of elements attract the electrons when their atoms are combined. For this purpose, the concept of electronegativity is introduced. This ionization energy and the electron gain enthalpy are the properties of the isolated atoms of the elements. There has been a need to have a comparing the scale relating the abilities of the elements to attract the elements to attract the electrons when their atoms are combined. When the atoms of different elements are combined, to explain about its attracting power, we need one scale. Okay, for this purpose the concept of electronegativity is introduced. Okay, atoms of different elements are combined, no? So to explain about its attracting power, we need one scale. Okay, for this purpose the concept of electronegativity is introduced. Okay, there has been a need to have comparing a scale. Okay, there has been a need to have a comparative scale relating the abilities of elements to attract the electrons when their atoms are combined. For this purpose, this electronegativity concept is introduced. So what is the meaning of electronegativity? Now we will discuss. The electronegativity of an element is defined as the relative tendency of its atom to attract the electrons towards itself when it is bonded to the atom of another element. So atom of one element, when it is combining with the another elements, so it is attracting the electrons towards itself. Okay, this capacity is called as electronegativity. Okay, so the electronegativity of an element is nothing but the relative tendency of its atom to attract the electrons towards itself when it is bonded with the atom of another element. So when the atom of one element is combining with the atom of another element, so in that one of the element is attracting the electrons towards itself. Okay, that only called as electronegativity. All the factors that influence the ionization energy and the electron affinity of an element influence the electronegativity values of those elements. Okay, so which factors influence the ionization energy and electron affinity, that factors also influence the electronegativity. Because of this, Millikan proposed that the electronegativity of an element is the average value of its ionization energy and electron affinity. So the factors which are affecting the ionization energy and electron affinity, that factors only affecting the electronegativity. That's why Millikan proposed the electronegativity like this. What is that? Electronegativity of an element is the average value of its ionization energy and electron affinity. So electronegativity equal to ionization energy plus electron affinity by 2. Okay, this electronegativity values of the elements decreases as we go down in a group and increases along the period from left to right. Okay, so electronegativity values of the elements decreases in groups as we go down, and it is increases in a period from left to right. Okay, the most electronegative element is fluorine and the least electronegative element is cesium. Okay, we will discuss one more topic, metallic and non-metallic properties. Metals generally shows less electronegative characters. Okay, metals generally shows less electronegative character. So in compounds, they generally shows a tendency to remain as positive ions. Okay, metal generally shows the less electronegative character, but in compounds they generally shows a tendency to remain a positive ions. This property often termed as electropositive character. So metals are electropositive elements, means metals generally having less electronegativity, but when that forming the compounds. Okay, compounds means atoms of one different elements combined together that give a new substance that form a compound. So in compounds, metals generally shows the tendency to remain positive ions. For example, sodium is there, that we can say one of the example for metal. Why? Because its atomic number 11, electronic configuration 1s2, 2s2, 2p6, 3s1. Last shell which one? 3s. In that how many electrons are there? 1 electron is there. So if in the last shell 8 electrons are there, then it is stable. If 8 electrons are not there, it is not stable. Okay, so it is easy to lose 1 electron or easy to gain 7 electron. It is easy to lose 1 electron. So that's why this sodium losing 1 electron. When it is losing the electron, which symbol will come? Positive symbol or negative symbol? Positive, and it is called as cation. Okay, so like this, in compounds generally so metals generally shows less electronegative character. In compounds, they generally show tendency to remain as positive ions. When they are forming the compounds, these metals showing the metals having positive. So metals having a tendency to remain as positive ion, means when that are forming the compounds, these metals getting positive charge. Okay, means that will be like a positive ions. Okay, This property is called as electropositive, means metals are losing the electrons and that form cations, then plus symbol will come now. That character is called as electropositive character. Sodium, magnesium also. Okay, magnesium atomic number 12. Its configuration 1s2 2s2 2p6 3s2. Last shell 2 electrons are there. It is easy to lose 2 or easy to gain 6 easy to lose 2. Losing 2, no, Mg plus 2 will come. Like that, when it is losing the electron, plus symbol will come, no, that is called as positive character. Okay, so then we can call that as a electropositive character. So metals are electropositive elements. Okay, what about non-metals? Non-metals are generally more electronegative due to their smaller atomic radii. Okay, non-metals are generally more electronegative due to their smaller atomic radii. Okay, so once you observe the element of third period, what are there? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. So we know that sodium, magnesium are metals. Aluminum and silicon are semi-metals. Okay, and phosphorus, sulfur, chlorine are non-metal. So we find metals on left side and non-metals on right side of the periodic table. This means metallic character is decreases and non-metallic character is increases as we move along a period from left to right. So here already we discussed, if the element, if that is losing the electrons, then plus symbol will come, means it will form positive ion, means that is called as cation, like sodium, magnesium. Okay, so this character is called as electropositive character. Like that, some elements are taking the electrons to get octet. For example, chlorine atomic number 17. Its electronic configuration 1s2 2s2 2p6 3s2 3p5. Which is last shell? Third shell. Third shell, what are there? 3s2 3p5. Means total 7 electrons are there. It is stable or not stable? Why? Because it not obey the octet. So to become stable, how many electrons are there? Less. 1 electron is less. So to chlorine, it is easy to gain 1 electron or it is easy to lose 7 electrons. It is easy to gain 1 electron. So this chlorine is taking that 1 electron from another element like sodium. Okay, so then sodium chloride will form. Okay, this chlorine is taking the electron from chlorine is taking the electron, no? Then which symbol will come? Negative symbol will come. Okay, so means negative ions will form. So that is called as anion, chloride ion. Then it is called as anion. So this character is called as electronegative character. So if you observe in the third period, in the sodium, magnesium losing the electrons. Okay, so these are called as metals. Metals are electropositive. Non-metals are electronegative. Metals are electropositive and non-metals are electronegative. So sodium, magnesium losing the electron, no, that's why these are called as metals. And aluminum, silicon are semi-metals. And phosphorus, sulfur, chlorine, these are non-metals. Phosphorus, sulfur, chlorine, these are non-metals. Why? Because phosphorus atomic number 15. Electronic configuration 1s2 2s2 2p6 3s2 3p3. Last shell 5 electrons are there. Okay, to get octet 3 electrons less, no, that is, it is easy to gain 3 electrons or easy to lose 5 electrons, easy to gain 3 electrons. That way taking 3, no. So that's why that is non-metal. Means metals are giving the electrons, non-metals are taking the electrons. Okay, so this phosphorus taking the electrons 3, sulfur taking the electrons 2, chlorine taking 1 electron. So which are taking the electrons, that we can call as a non-metals. Which are giving the electron, that we can call as a metals. Okay, so in the sodium, magnesium giving electrons, no, that are metals. Aluminum, silicon are metalloids or semi-metals. And phosphorus, sulfur, chlorine taking electron, no, that are called as non-metal. So in this we find that in the periodic table, left side, what their metals are left side. In the periodic table, we find metals on left side. In the periodic table, metals are present left side. Non-metals are present right side of the periodic table. In the periodic table, left side metals are there, right side non-metals are there. Means metallic character decreases, means sodium, magnesium, like that we are going, no, that are metals. If you are going like that towards the right side, non-metals are coming, means metallic character is decreasing and non-metallic character is increasing along the period. Okay, let us take 14th, means 4th A group. Let us take 14th 4th A group. In 4th A group, what are there? Carbon, silicon, germanium, okay, and tin, lead. Here also we know that carbon is a non-metal. Okay, carbon is a non-metal. Silicon, germanium are metalloids. Silicon, germanium are metalloid, and tin and lead are metals. Tin and lead are metals. So we find that non-metals, particularly at the right hand side top, metals at the left. So we find that non-metals, particularly at the right hand side top, and metals at the left and right hand side bottom of the periodic table. Okay, non-metals are particularly right hand side top and metals at the left and right hand side bottom of the periodic table. Okay, the periodic table right side bottom, and in the periodic table left side metals will be there, non-metals are at the right hand side top will be there. This means the metallic character is increases while non-metallic character is decreases in a group as we move from top to bottom.